It is a great pleasure for me to be with all of you this afternoon, and I want to start by thanking Paul Davey and all of the different people that have been involved in making this event possible. And I want to also start by saying that while I'm very happy to be here to discuss this important and interesting topic, I'm also a little bit uneasy because this is obviously an emotionally charged subject, as you can all appreciate and imagine. Because any potential answer that we have to the question of origins in the past, where we come from, automatically goes into questions of purpose. Why are we here, the present? And also even in destiny, where are we going? And so you can imagine that a lot of people would not accept to talk about this even with a 10-foot pole. So the question is, why am I here talking about this today? Well, generally speaking, what is happening in our culture and our society is that only one side of the story is being heard. And I know because I used to be on that side also. And yet there are many scientifically, rigorously minded people who beg to differ, who have a different perspective. And so the goal today is simply to inform, to give you all the facts, so that whether you're going to be on one side of the debate or the other, that at least you have a chance to have all of the information so that you can have an informed conclusion. And for those of you who think that what is going to be showed today is going to prove categorically one position over the other, you might be disappointed. Because the reality is, when you break it down to the fundamental questions, there are also aspects of faith that are involved, whether you are on one side or the other. But that doesn't mean that there's nothing to talk about. In fact, there's a great deal to discuss. It's sort of like a court setting. You have a chance to hear both sides make their case and look at all of the evidence, so that hopefully you're going to be able to get to a position where that evidence is going to allow you to come to a verdict beyond a reasonable doubt. And so that's the goal today, to have a chance to look at all of this evidence for you to have an informed position. Now, these presentations that you're going to see over the next 2 days, today and tomorrow, are a trimmed down version. There are longer versions that I have been giving in the past. So this is a shortened version. So it's really scratching the surface. There's so much to say on this topic, as you can imagine. But essentially, we're going to try to look at the core questions and the evidence that is involved in all of these things. These presentations, as you just heard, are broken down into 4 parts. And so we're going to start right away with part 1, which essentially examines the gap that exists between inanimate matter and animate matter. What is there in the physical laws, in matter and energy, that we understand that would potentially allow us to bridge that gap between non-life and life? So that's concepts of physics and chemistry. Afterwards, we're going to look at part 2. We're going to step on the other shore, the shore of life, and examine the fundamental unit of life, which is the cell. Remember that at the time when the theory of evolution was framed, the cell was a black box. It was not understood. And we've now opened this black box and understand more and more about the inner workings of the cell. So to re-examine these questions according to modern knowledge. Part 3 then, tomorrow, is going to be climbing to the highest heights on that shore of life, which is higher organisms like you and I. Not just single cells, but a complex arrangement of cells that allow us to exist as higher organisms. And finally, part 4, which is going to be looking at the power of science, but also some of its limitations as it struggles to deal with some of these fundamental questions that we have. And so essentially, what you're going to notice is that this is telling a story. And just like any building, when you start constructing a building, you need to have foundations. Foundations are not very pretty. They're not very exciting. They're actually kind of boring, but they are important. And so as we begin today, you might listen to some of the evidence that's being presented and say, well, that's interesting, but that's not really conclusive. Please be patient, because this is a story that is gradually going to unfold. And a lot of the most important information is actually going to be given tomorrow. So today we're going to lay the foundation. So let's begin. I want to start with a little cartoon here that was actually published in Punch's Almanac in 1882. And this cartoon depicts the whole idea of evolution, not long after the theory had been framed. And you see that from these 5 letters, C-H-A-O-S, out of chaos comes something. We don't know how, we don't know when, but essentially this form of life that comes eventually as time goes on, progresses and changes into these, well, up to this interesting looking barbarian here, to eventually this nice, refined British gentleman. And so there's 2 things that I want to point out here in this cartoon. First is, of course, the image of Charles Darwin himself, the scientist who framed this theory, formulated in a scientific manner, and that is very well known today. A lot of the ideas of evolution already existed at the time of Darwin, but he's the one that really brought it all together in the way that we know today. The other thing that I want to point your attention to is this clock in the background, which represents, of course, time. And that's the question that every single one of us has to answer for ourselves. And that is time, coupled with matter and energy, is able to produce all of the different living creatures that we find around ourselves, and ourselves included? That is the question, and it's the most important question that we all have to answer for ourselves. And again, the goal today is to give you more and more scientific information to hopefully come to a solid conclusion. Before we get going, there's one more thing that I need to do, which is to define the term evolution. The word evolution is a word that is very chameleon. It can mean many different things. And so during these presentations, every time that I use the word evolution, this is what I'm talking about. I'm talking about a process that is able to occur on its own from matter and energy, using strictly time as its magic ingredient to allow the appearance, the emergence of all these forms of life. In scientific circle, this perspective is called reductionism, or material reductionism, which says that matter and energy alone are sufficient to explain everything that we see around and inside of us. Now, what is science? Science is a very complex endeavor, but at the same time, every time that we are seeking to understand and to explain the world that we live in, we are doing science. And I've been very fortunate, as you heard earlier on. I've had the chance to study biochemistry, organic chemistry, to do research for many years, work on many different programs, and now I have the blessing of being able to teach science. I'm passionate about science. I love science. Science is an amazingly powerful tool, but like any tool, it must be properly used in order to do good. And so again, this is what we're going to be looking at today. Science can be divided in two broad categories, and this is important because even among highly educated people, this distinction is not always recognized. Not to say that it's black and white, it's actually a continuum, but you have two opposite poles in this continuum, and here are the two categories of science. The first one is what we would call empirical or operational science. It establishes facts by direct experimentation. You are directly studying the phenomenon that you're trying to describe. And you're also able to reproduce it. And so if somebody disagrees with some of your conclusions, they can go back and look at the data and repeat it for themselves. This is deductive by nature. It has a higher objectivity, and there's less room for individual interpretation. But there's another branch of science, which we call historical or forensic science. And in this type of science, we establish fact by indirect experimentation. We are not able to directly study the phenomenon that we are trying to explain. And so essentially what we need to do is to use the empirical operational science to gather clues, evidences, in order to support some sort of model to try to explain the phenomenon that we're looking at. This is inductive by nature. It has a higher degree of subjectivity, as different types of hypotheses can be used to explain the phenomenon that's observed. There is more room for interpretation. Let me illustrate this principle by just making an analogy. This is Blue John Canyon in the US, beautiful canyon. And if I ask the question, what is the composition of this sedimentary rock? What type of science are we dealing with? Well, we're dealing with empirical or operational science mainly. You can take a sample of the rock, bring it to a lab, digest it, analyze, and say how much silicon, oxygen, iron that you have in this specific rock. If somebody disagrees, they come and take another sample and they can reproduce the experiment. But if I ask the following question, what is the age of formation of this rock? That's also a scientific question. But now that type of question cannot be answered by the empirical operational science on its own. You cannot reproduce the fact. You cannot go back in time and see when this has been done. So essentially what you need to do is to use historical forensic science to gather clues for and against different hypotheses, different models, and to see which one is going to best fit the data that you have. So as we can see, empirical science is powerful to study reproducible events, but it is powerless to study non-reproducible events. And historical forensic science studies non-reproducible events by using this method in order to gather evidence for or against different hypotheses. So these are the two different broad categories that we find in science. And so, of course, if we ask the question, well, what about the origins of life? What are we dealing with right now? Well, of course, as long as you cannot reproduce life, or if you can't go back and see when it had appeared, you're essentially dealing with this type of science. So again, the interpretation of the empirical evidences is crucial, because to being able to construct a theory that is going to be solidly laid upon a foundation is a challenge, because you're not directly able to do these things. So even before evolution is possible, certain things are required. The first of which is matter and energy. Where do these come from? This comes from one of my old textbooks in biochemistry, right from the beginning. Some 20 billion years ago, the universe arose with an explosion. Every single atom in the universe was born in the Big Bang. So even before evolution is possible, you have to look at matter and energy. Where do they come from in order for these things to be even suggested? Well, we find ourselves with more questions very often when we look at these so-called answers. Living things are composed of lifeless molecules that conform to all of the physical and chemical laws. And here's the key. Yet living organisms possess extraordinary attributes not shown by collections of molecules, inanimate molecules. And that again is where the debate and the questions are. Where do the properties of life come from? Is it strictly coming from matter and energy, these extraordinary attributes, or is it pointing to the need for something beyond just matter and energy? Enough talking about science, let's now start talking science. So question part one, as I said, is examining the gap that exists between inanimate matter and animate matter. And so the question is, do we have any evidences in scientific data that would allow us to bridge that gap just using matter and energy? And so remember that life is found all around us in so many different ways. And so it's tempting to believe that life is able to appear just on its own. And in fact, there's so many cases, especially in past history, where people believe that, yes, we have empirical evidence that life is able to appear on its own. This is called abiogenesis, or spontaneous generation. Well, that theory was dealt a deadly blow by the coming of Louis Pasteur, which eventually did some experiments which categorically demonstrated that if you destroy all forms of life, and even the spores that could lead to life, that life will never appear on its own from matter and energy. These, of course, are empirical evidences. And he stated that in the biogenetic laws, that only life can give rise to life, and that like can only give rise to like. Again, these are empirical evidences that still stand today. But what about that theory of evolution that proposes that over long periods of time, that these principles would have been violated? You need to have some sort of evidence that would allow you to get, baby steps, so that eventually over long periods of time, these principles could have been violated or gone above and beyond. Several decades ago, experiments were done by Stanley Miller and company in order to try to answer that question. Chemical evolution. Is it possible that the fundamental building blocks of life would be able to appear on their own? And so what they did is they tried to mimic what they believed to be Earth's early atmosphere using methane, ammonia, water, and hydrogen gases. They introduced this source of heat, sources of electricity, and refluxed the whole system with a trapping mechanism to identify what are the compounds that are being generated by this system. And lo and behold, they discovered in very, very minute quantities in an ocean of all kinds of tar, essentially that's what it looked like black tar, small trace amounts of simplest amino acids. And right away, this was published in the world as being a potential solution to the question of chemical evolution, that the fundamental building blocks of life, amino acids, from which all the proteins are built, are able to appear on their own without the help of any hand. Well, careful analysis of these experiments and some of the conclusions reveal that things are a little bit more complicated than they first believed. First of all, this type of apparatus did not appear on its own. It required a lot of thinking and engineering in order to do these experiments. That's the first thing. The other thing is that these amino acids, the simplest amino acids that were formed, one of them was alanine. It was a racemic amino acid. You might not know what racemic means, but essentially most of the molecules that we find in life can be two mirror images, sort of like two gloves for the different hands. And so all of life is one mirror image, only one of the two. And this type of process affords a mixture of the two. So it still doesn't explain how you could have only one of the two possible mirror images. Second is the atmosphere that was generated is toxic to life, extremely toxic to life, and also excluded oxygen. And that was excluded for obvious reasons, because if oxygen would have been in there and you would have ignited it, instead of trying to form life, well, the life in the lab would have been destroyed. So that's the obvious reason for excluding oxygen. But that creates a lot of problems because we know that oxygen is essential for life. Furthermore, the reaction conditions that were being used in this setup in order to generate even the simplest amino acids were actually favoring the destruction of these not gentle, but delicate molecules. And so this is why the trapping mechanisms was necessary. And so also, the presence of water, sometimes we hear in the news, they've discovered a new planet, and there's water on that planet, so maybe there's life. As if because there's water, that you're automatically going to get life. Water, and this is so important, water has no life-giving properties. Water has life-sustaining properties. Fundamental difference here between the two. And in fact, the presence of water is not a help to the formation of these complex biomolecules that we are familiar with. It is a hindrance, because in the presence of water, proteins, nucleic acids, phospholipids, all of these structures will gradually over time hydrolyze. They will break down in the presence of water. So water is in fact a challenge. But even if you forget all of these complicated details about why this experiment doesn't really address the key questions concerning this debate, I want you to remember this simple analogy. Let's say that we're walking in the forest and we see let's say copper ore and aluminum ore, and we see a petroleum source, oil. Finding these three different aspects, does that mean that we found the explanation for this? Not at all. Not at all. You see, even though the plane is made from all of these different substances and uses it, we know that these naturally occurring components will not gradually and spontaneously organize themselves in order to make a plane. And this is what we would call Polanyi's principle, that machines and living systems transcend, go beyond simple material explanations. You see, amino acids are lifeless molecules. They are, to a cell, what iron ore or copper ore is to a plane. Finding one is good. It helps you understand the physical existence of the structure, but in no way does it solve the question about the origin of this complicated structure. Equating life to its basic components actually reveals ignorance about the complexity of the question that is at hand here, okay? So if it doesn't work with the plane, finding simple amino acids for life also doesn't solve the issue at all. That does not bridge the gap, essentially. But still, very often we hear people saying, well, listen, we are in a huge universe, and billions of years are available to us for things to have happened. Well, that's an interesting point, right? This is what we would call the law of large numbers. Oh, let me just go back here. Stanley Miller, at the end of his life, he wrote the book, and in that book he said, the problem of the origin of life have turned out to be much more difficult than I or most other people envisioned. So indeed, when you take a step back and you look at the big picture, you discover that these experiments actually bring more questions than answers. So coming back to the concept of probabilities and deep time, billions and billions of years, wouldn't that be possible to allow the emergence of life? Well, the first thing that is imperative for us to understand is that time can only allow what is possible. Time cannot allow what is impossible. Do we agree on that? And so the question then becomes, well, how do we know what is possible and what is not possible? That's the challenge. And so in order to try to answer that question, we have to go back to the fundamentals. All of science is a very complicated structure of knowledge, but all of it is built upon some very basic fundamental principles. And so we need to take a step back and ask the question, how do we know what time is possible and what is not? Estimating a probability or a possibility requires that we understand the governing laws of matter and energy so that we can discern between what is possible and what is not. And this brings us to the concept of thermodynamics, those fundamental laws upon which all of science is constructed. These are the laws that govern all of matter and energy. This is the basic foundation upon which everything holds. And so we need to ask the question, what do these laws teach us about our presence in this universe, the presence of life? Well, these laws, I'm going to look at the first two, the first and the second laws of thermodynamics. The first one I describe with the two C's, causality and conservation. Causality is essentially that all effects have adequate causes. Everything that happens in this universe happens because of a specific cause. That's why we have laws. That's why things are predictable. Nothing can create itself, being both, obviously, the cause and the effect. This is the law of causality. The second C is conservation, that the amount of matter and energy in this universe is constant. We see all of this innovation that we are able to do, but we must remember that the laws, the fundamental laws of this universe are based upon not innovation, but upon conservation. This is the ruling principle. And what does this tell us about the questions that are before us today? Well, when we look at the origin of the universe, it basically is telling us that we have a problem. Because either the universe is eternal, which goes against what these laws are telling us, that you have to have a cause for every effect. Well, where does the universe come from? You don't have an answer for that. So that leads to a problem. And if you say, well, there has to be something greater and beyond the universe, you have to bring into mind that is going to be above time, space, and matter, the dimension, the realms of this universe. So again, it doesn't matter whether if you're on one side or the other, there are fundamental questions for which we don't have definite, clear answers. It goes beyond our ability to comprehend. Some scientists have said, well, that's not really a big problem. We're just going to call that a singularity. You know, the universe, well, we'll just say that the universe always existed. And then you have to ask the question, well, the Big Bang, it exploded. Why did it explode? What caused it to explode? We don't have an answer for that. You see? Well, we're just going to call that a singularity. What is a singularity? Well, if you look at the definition of a singularity, it is an event that occurs in the physical universe for which we have no physical explanation. I'll have another word that fits the same definition. So again, the reality is, it is a challenge for all of us when you break it down to the fundamentals. And then we look at the origin of life. Well, if life would be simply the result of matter and energy coming together according to those physical laws, where are the laws that allow the emergence of life? And here I quote Paul Davies, new scientist. He says, there is nothing in the known laws to compel matter to organize into life. There are no laws, no principles that will guide matter to organize into the living systems that we see. There are none. So again, the dilemma is huge for all of us. And here I bring in this debate, two big names, Einstein and Darwin. Einstein essentially, he said that he was very interested in the function of the universe, in the origin of the universe, and he basically believed that there has to be a creator, a first cause, the prime mover who created the universe in the beginning and then stepped back in order for the universe to unfold and eventually life to appear. So even someone like Einstein believed that there has to be something beyond the universe. That's something important to keep in mind. What about Darwin? Well, Darwin's book is not called The Origin of Life, is it? What is it called? Origin of Species. That's right. In fact, Darwin did not try to explain the origin of life as much as he tried to explain how life, once it's there, is able to change over time. Origin of species, speciation, change over time. And in fact, when you go back to the original edition of Origin of Species, in the last chapter, Darwin himself said that, of course, that first form of life had to have life breathed into it by the Creator. Those are his own words. And unfortunately, there are very few people today that are aware of this debate who knew these things. the information is not being shared as it ought to be. And again, this is the goal today for all of us to have all of the information. They didn't believe in the God of the Bible, mind you, but at least, scientifically speaking, they recognized the need for something beyond just matter and energy. Let's move on to the second law. Many things are happening around us. Why are these things happening if this universe is just a universe of conservation? The two E's, energy and entropy. The first one is Gibbs free energy. And this form of energy converts gradually to a form that is unable to do work. And so essentially this is a change that is taking place that is both directional and irreversible. Think about it this way. The universe is like a huge candle that is gradually burning out. The energy content that is found inside of it is gradually being transformed in a form that is not able to do work anymore. Once your candle is burned, did the energy vanish? Did the matter vanish? No. They just change form. And that energy that was contained in the original form has been spent so that it's now used up. And so this is exactly what we see happening in this universe. The energy is going down, it's going downhill steadily, and there's no way to stop it. This is what's happening. The second E is entropy, which essentially means disorder. What is the driving force behind all of the things that happen in this universe? Disorder. Sounds like a strange answer. Systems spontaneously move from ordered to disordered, spontaneously, generally speaking. In general, matter is governed by disordering principles. Let me just illustrate very simply. I'm on the side of the ocean and I build a little house with the sand. Do I come back the next morning and I see a castle? No, it's gone. Why? Because again, the natural laws are such that things will naturally go towards disorder rather than order. So again, what does these fundamental laws tell us about the questions that we're looking at today? Well, first of all, since energy is going down and since disorder is going up, it means that as we look back in time, it means that at its inception, at its beginning, however and whenever that was, the universe had a highest highest energy and lowest disorder at its inception. That's when we look back in time. What about when we look forward? Well, again, as we just said, things are running down. And so the universe is actually moving to a place where there will be minimal or no energy available and maximal disorder will be obtained. This is what physicists call heat death, when there's no more available energy to do anything. Not very uplifting, is it? But the point is this, is that the direction that it's moving is the exact opposite direction from where things need to go in order for life to appear. Life would not be sustainable in this situation. Let's take a step back and just listen to Sir Julian Huxley, him who was called Darwin's bulldog, and how he defines evolution. He basically says that evolution gives rise to an increase of variety and an increasingly high level of organization in its products, a single process of self-transformation. So essentially we need to go from nothing in terms of all the structures that we find in life to all of these, from low energy to high energy, from disorder to order. So this is the direction that these laws need to go in order for us to have a chance to explain how life might have appeared on its own. But the reality is that things are moving in the opposite direction. The train is going west when in fact it needs to go east. It is not just that the laws are not giving us an answer or helping us. They're not silent. They are speaking, they're pointing, and the direction in which they are pointing is the opposite from what is necessary in order for life to appear on its own. So of course you're going to say, well, this kind of argumentation, all scientists are aware of this. So surely there's a counter-argument to this kind of argumentation, and of course there is. And the chief argument that is used is as follows. Because the Earth, where we find ourselves, is not what you would call a closed system. It is an open system. So here's the argument that you would typically hear. The second law permits parts of a system to decrease in entropy, to do the opposite, as long as other parts experience an offsetting increase. And this is completely true. Thus, our planet as a whole can grow more complex because the sun pours heat and light onto it. Now, the first thing that we need to recognize is that the second law applies not just to open systems, but also to closed systems, to both of them. There are no known violations of the second law of thermodynamics. This law applies equally well to open systems. Generally speaking, Adding energy in a system, open or closed, is going to speed up reaching lower energy and maximum disorder. In order for energy to be constructed and used in a productive way in order to generate order, certain ingredients are typically necessary. Let me give you an illustration. I worked in the lab for many, many years, doing drug discovery, the good kind of drugs. And essentially, we had all of these molecules, all of these compounds around us, and we're trying to take these compounds, put them together, make more complex structures that hopefully are going to have interesting and useful biological activity. And so by me just, bringing a lot of energy, in the lab, like an explosion, is that going to lead to the formation of more complex molecules? Quite the opposite. In fact, that energy is going to speed up the formation of molecules that have lower energy, such as carbon dioxide, water, and even nitrogen gas. And in terms of disorder, well, the explosion will speak for itself. So raw energy on its own will not solve the situation. I'll give you one more analogy. Most of you came here by car today. Requires energy in order to do the work, to come here. But you taking gasoline and just pouring it on the car and lighting it on fire is not going to be very productive. In fact, you're going to destroy the car. The only way that raw energy can be used in order to do something productive is thanks to the complex engineering of the car. So that means you need to place that gasoline inside the tank so that it reaches the engine under the right conditions in order for that raw energy to then be used productively. And that's the key. So indeed, life on Earth is able to grow more and more in terms of its highest energy level and in terms of its complexity. But that is because of what? That is because of the complex engineering, biochemical engineering that we find in plants that is able to harness, to capture the energy that comes from the sun and then use that raw energy in order to power the different biochemical mechanisms that allow life to grow and to become more and more complex. And this is an amazing system. This is just a snapshot of all of the different things that are happening in plants in order for this process to be possible. So, conclusion, energy alone does not produce order from disorder. In fact, generally speaking, it will do the opposite. Furthermore, this energy must be harnessed in order to be productively put to work. Again, following Polanyi's principle. Us, our culture, our society, we are dealing with an energy crisis. I mean, we've had a bit of a respite with the oil prices, but they're back on the rise, and they're going to keep rising. And we know that it's a problem that our society has not solved, the energy crisis. We have limited amounts of oil, and so eventually it's going to run out. And then we hear about this hydrogen economy, and if we were able to use hydrogen, we would solve all of our energy problems. The problem is we don't have hydrogen, you see? We're back at square one. How does life solve the energy crisis? Well, we talked a little bit about it. Essentially, plants, in order to make the sugars, they don't eat. Plants don't eat. So how do they live? What is their source of energy? They are what we call autotrophs. They make their own food. They take the carbon dioxide in the air and the water vapor, okay? And essentially what they do is they build their own high energy complexity structures, which is sugars, and release oxygen in the process, and they're able to feed from that sugar. And so what is the energy source that allows this to be possible? Well, that's of course the sun. The power of the sun that is being harnessed by the biochemical pathways of photosynthesis. They're actually able, sort of, to split water and generate the equivalent of hydrogen. It's not hydrogen gas, but it's the equivalent of hydrogen gas, and they're able to use the energy from the sun to generate these structures here. But this is only half the story, because we know that we don't just have plants around us, that we also have animals, ourselves being living organisms. I mean, can we use the sun to power us? Absolutely not. If you go in the sun, the only thing that you're going to get is a tan, hopefully. Or you might burn if you stay too long. But it is not going to give you energy. You are not an autotroph. You are a heterotroph. You have to eat in order to get your energy. And so that means that we, animals, are going to consume what the plants have generated from the power of the sun in order then to do what? To power our own living organisms. And so what happens is we exhale carbon dioxide and water, and essentially we extract the energy, the chemical energy that has been stored by the plants from the sun in order to allow us to do the work that we do. Everything is indeed powered by the sun, indeed. But the only way that the energy of the sun is of use is that all of the complex engineering that we find in plants is in place and functional in order to capture that energy and to drive the existence of life on this planet. And what's also interesting is that you need to have both together at the same time in order for this cycle to be possible. So it's sort of like the question, well, who came first? Well, they both need each other at the same time. And essentially you have this beautiful two mirror images on the global scale that must be in place right from the beginning in order for life to be possible. And so essentially, this brings us now to the end of our first part, looking at the gap that exists between matter and energy. And as we study all of these different scientific principles that govern matter and energy, we discover that there is nothing that allows us in a simple, direct manner to bridge the gap. In fact, the more that we study and discover evidences about how life functions, the wider and the wider this gap seems to get. The more difficult and the more challenging it becomes to try to come up with something that will allow you to bridge that gap. Imagine taking a walk in the desert and coming across this. I mean, it's just stones, it's just rock. But you have a whole set of complex stairways and channels and rooms in these structures, but they're just rocks. I mean, the laws of the universe and everything that we know about matter and energy can explain very easily their existence in terms of matter, in terms of position, but yet none of us would dare to suggest that something like this could appear on its own. And what is this compared to a cell, compared to like one of us? So indeed, while material laws can explain physical existence of different structures, life being included, they cannot account for their design and construction. So something else is required in order to explain this. So we're going to take a 5-minute break, and then we'll come back and complete part 2. Thank you.